How important are innovative sealing solutions for today's technology trends? Welcome to a new episode of our podcast, Alles DICHT. Today, we're exploring this question together with Parisa Burger, Business Development Manager at Freudenberg Sealing Technologies. We'll look at one specific example, sealing busbars and busbar pins. Great to have you here today, Parisa.
Thank you for the invitation and the opportunity to participate.
Our pleasure. Well, when people think about seals, they usually imagine familiar round shapes, O-rings, flat seals, and other standard designs. But things change when the components you need to seal are rectangular or extremely small, and when these components also carry electricity. In those cases, you have to move beyond the traditional world of seals, and that's exactly where new challenges begin. Trends like electromobility are creating new requirements in this field.
Yes, we should not be underestimated.
So we have already seen that in many areas. When people talk about electromobility, they usually focus on charging times, the availability of charging infrastructure, or battery development. Seals are rarely part of that conversation, right?
That is understandable, since seals are usually invisible and their importance is often underestimated. But in our e-mobility projects, seals actually play a crucial role. They are directly connected to the topics you mentioned: battery development, the sealing of inverter and e-motor systems, and similar applications. In fact, e-mobility simply wouldn't work without modern sealing technology. And that, in a way, also answers your question.
Great. I think that clears things up. But let's move on to another technical solution that opens up new possibilities for e-mobility and other applications involving electricity-conducting components. We're talking about the sealing of bus bars and busbar pins. And maybe a quick introduction for our listeners. What exactly are bus bars and busbar pins?
Let's start with bus bars. They are also known as conductor rails. I'll come back to the seals for bus bar pins in a moment. Bus bars are essentially cables that distribute electricity within a vehicle. You could think of them as electricity highways. They are typically made of copper, aluminum, or other conductive metals, and they often have a rectangular cross-section. While this shape is very space efficient and highly effective, it also creates a real challenge. When it comes to sealing, the corners in particular are typical weak points where liquids can penetrate.
Could you maybe give us a short example to explain why a rectangular shape makes sealing more challenging?
I'd be glad to. Let's take the example of an electric motor, the heart of many electric vehicles. For the motor to work, it has to be connected to the power electronics, the so-called inverters. And that's where bus bars come in. They transport the electrical current from the motor's stator to the inverter. At first, that sounds quite simple, but in reality, it's a real engineering challenge. Most electric motors are oil-cooled, which means the bus bar has to pass through the motor housing and remain completely leak-tight so that no oil can reach the sensitive power electronics.
I'm familiar with this from other projects. In some cases, more complex shapes were sealed by casting or bonding. But those approaches are often very time-consuming, and in some cases, they can place significant restrictions on the vehicle design. Now you're introducing a new technology, the overmolding of electricity-carrying components to achieve media tightness. So, how should we picture this?
As you mentioned, the common solution so far has been what is known as spotting. In this process, sealing is done using epoxy resins or silicone. Of course, this requires a certain amount of space. In our process, the rectangular bus bars are overmolded with a special elastomer layer or sealing geometry. This creates a chemical bond between the elastomer and the metal components. And that bond forms a seamless, media-tight seal. You can picture it like this. The conductor and the seal are no longer two separate parts. Because of this chemical bond, they essentially become a single component.
Okay. And what advantages does this offer for car manufacturers?
They help save space in the vehicle, and they reduce both time and costs during production. At the same time, this technology increases the overall reliability of the vehicle. As I mentioned earlier, it eliminates one of the previous weak points when sealing these components.
You just mentioned an elastomer layer as the bonding element. Which materials do you use for this?
We use advanced materials such as FKM, EPDM, HMBA, or AEM from our broad material portfolio. These materials have very specific properties. They are both flexible and highly stable when exposed to media, such as oil or coolants. They are also resistant to very high or very low temperatures, and even to mechanical stress. By combining these materials in the right way, we can create sealing solutions that meet a wide range of requirements.
Okay, so you just mentioned advanced materials. The EU is currently discussing whether sealants and adhesives should even be classified as advanced materials. So do you really mean advanced materials in this case?
If these materials and the media-tight composite they are used for are not considered advanced, then I'm not quite sure what would qualify.
Okay, so making progress in mobility really depends on materials like these and on the solutions built around them.
Absolutely. Without advanced materials, many technological trends would simply not be possible, from electromobility, which we've been talking about today, to digitalization, and even modern energy systems.
Is this media-tight overmolding only suitable for electricity highways?
No, our busbar sealing is also suitable for low voltage applications, such as busbar pins. These are essentially very small busbars, conductor rails in a much smaller form, which we already mentioned earlier.
So these are parts that require sealing on a miniature scale?
Yes, here is the main focus on multi-pin connectors and other small plug connections, where numerous pins are arranged in very tight spaces.
So what are the main challenges with these components from a sealing technology perspective?
The specifications for sealing these miniature components include requirements such as tightness, protection classes, for example, EP ratings, material compatibility, and thermal stress. By using elastomer seals, we can reliably seal even the smallest geometries, and if required, we can also integrate multiple functions into a single component.
What do you mean by integrating multiple functions or sealing functions?
With precise material selection and intelligent seal design, we can implement features such as tolerance compensation, easier assembly, or the specific optimization of the entire module.
So, would other functions also be conceivable?
And that has a major advantage. We make sure that the seals and the installation space are perfectly coordinated. This allows us to integrate additional functions directly into the design. For example, centering features or fastening elements. In the end, this saves time during later assembly, reduces complexity, and creates a solution that is not only media tight, but also easy to install.
So, in other words, the technology ultimately provides an innovation toolbox for many areas?
Yes, you could say that.
And this approach could also be used to solve challenges in other sectors?
Yes, as long as we are dealing with electricity conducting components. In other words, bus bars in different sizes, especially in applications where these components need to be sealed against various liquid or gaseous media and where they operate under very different environmental conditions.
Okay, so let's return to electromobility. What kind of prospects does this technology open up for the future?
Well, first of all, it makes vehicles more reliable, and that is crucial for users. After all, no one wants a car whose electrical or electronic systems fail after a short time. At the same time, this technology allows manufacturers to design their vehicles more flexibly and to make their production processes more efficient. And these technological options are important today because they allow new trends to be implemented quickly and efficiently.
A lot is currently being written about electromobility, and sometimes the impression is given that car manufacturers are lagging behind new developments. There are supposedly several reasons for this. On the one hand, innovations in sealing technology are sometimes viewed with a certain level of caution. On the other hand, in the automotive industry in particular, new products must go through extensive testing and approval processes before they can be used. So in this context, what kind of feedback is this new technology receiving from the automotive industry and from other sectors?
We have the same challenges as everyone else in e-mobility. We don't have many years of series experience, which is completely normal for a young technology. This is exactly why we are extremely thorough in our validation process. Our products are tested extensively to ensure absolute reliability, even without decades of field experience. The results are excellent, and our customers confirm this. The positive feedback from our customers shows that we are on the right track together. But we also have to provide quick solutions. In many areas, we have decided to offer prototypes that already meet the requirements. At the same time, customers have the opportunity to test these prototypes quickly and give us feedback so that we can initiate the next steps. This allows us to offer solutions that are not only innovative, but also robust, fast, and ready for series production.
I'm sure that this process also creates a certain amount of trust in the new technology, because many companies are entering new territory in this area. I'm also interested in another question. Earlier you said that you have just returned from China. Are there country-specific differences in the acceptance of sealing technologies?
Not as far as I have noticed. What is important is that the parts are leak tight. In China, I also noticed that sealing processes, both through potting and with O-rings, are very well known. But the Chinese market is also very interested in rectangular bus bars because they allow space-saving designs. And our solution is highly regarded there. And at this point, thanks to the great cooperation with our Chinese colleagues, we have also been able to successfully establish this solution in the Chinese market.
Sounds great. Let's finish with a more personal question. How does a team come up with such an approach in the first place?
Very early, we at Freudenberg asked ourselves how we could play an active role in shaping the transformation to electromobility. Our key strengths in materials and process development were the starting point. We realized relatively quickly that we could deliver significant added value in the busbar sector. And why? Because we have been able to vulcanize elastomers onto metallic substrate materials for decades. This expertise, together with our substantial elastomer portfolio, was the perfect place to start.
It's a relatively new approach. Ultimately, we are now moving from an earlier mechanical connection between material and seal to a chemical compound on 3 levels.
Yes, that's right.
What about this technology do you personally find exciting?
For me, it's very exciting to see that we are able to chemically bond elastomers with metal. And with this chemical compound, we ensure that despite temperature fluctuations below or above freezing, the chemical bond remains intact, no cracks form, so that everything remains permanently sealed.
Okay, so thank you very much, Parisa, for these insights into a new sealing technology that ultimately helps shape future trends, as you describe.
Thank you for having me here.
Okay, so today we learned that innovative sealing solutions are much more than just technical details. They are a key factor for many future technologies, which makes them far more important than is often assumed. This means that advanced materials, combined with expertise in sealing and manufacturing, and the willingness to explore new approaches, are essential for enabling these kinds of developments. With that, we'll say goodbye for today. Thank you again, Parisa, and we'll see you next time on Alles DICHT.